your digital media relation efforts with a faster and more efficient approach. It operates as an all-in-one management tool where you can spot collaboration opportunities, manage your communications with the media, automate workflows, monitor your link profile, report all your efforts to your customers. Many companies waste their time and money on strategies based on link buying and other outdated authority building techniques. These outdated procedures no longer give results. Link Affinity identifies potential collaborations with relevant media that will help build your brand's topical authority, resulting in a positive impact on your rankings. Nowadays, for a search engine to consider you a topical authority, you must become a real authority, and that is the mission of Link Affinity. With an advanced natural language processing system, it calculates semantic affinity by crawling up to 10,000 URLs for each prospect and analyzing their content, tagging, and ranking terms. Link Affinity performs an automated analysis of your link profile applying the naturalness algorithm. Naturalness seeks the balance between semantic affinity, authority, and penalty risk. Unlike other tools, Link Affinity devalues spammy links just like Google does, avoiding negative reports from automatic spam. You will save hundreds of hours by using our semantic automations. Let the AI work for you by selecting only those media opportunities that will add value to your project. Link Affinity's demanding quality filters will save time on manual analysis. Link Affinity integrates with tools like Ahrefs, SEMrush, Majestic SEO, or Systrix. With Link Affinity's complete management system, you can plan your campaign, organize your tasks, and reach out to your target media. You can also transfer the outreach to our team, who will exclusively negotiate with the media based on your collaboration request. Thanks to GDP technology and the experience of your clients, you can identify hot topics and suggest collaborations related to them to all kinds of journalists or content creators. Receive collaboration pitches from media looking for expertise. Link Affinity connects journalists with experts on topics relevant to their stories. Participate in interviews, provide information of interest, or collaborate on articles. You will be able to generate reports of all the activities carried out for your clients. Link Affinity changes the way of understanding and executing digital PR, ethical link building, and brand building campaigns. Due to this paradigm shift, Link Affinity has earned numerous industry awards, including Best PR Tool and multiple software innovation nominations. Thousands of clients have tried our method and have seen how easy it is to maximize their efforts and increasing productivity while improving final results. With our certified partner program for agencies, you will also have all of your clients on a single panel with personalized reports and much more. Request your free demo now at linkaffinity.io.
That's less headroom that I'm used to. Anyway, so yeah, let's talk about JavaScript, shall we? We haven't had that so far, huh? So today I'd like to quickly talk about what is rendering, because I think rendering is a term that is thrown away or around a lot and doesn't necessarily convey that much meaning. And then we're going to talk about how Google does it, because that has an impact on how you need to diagnose things. Okay, so what is rendering? Well, if you are making a website or have been making a website in the last, I don't know, 40 years or something, at this point, then you probably have used HTML. As you know, the HTML that you write isn't what the users see. In between, you might have a CDN, you might have a CMS, you might have anything in between that you want, but fundamentally what you're sending down the wire is HTML. But again, that's not what the user interacts with. So rendering generally is the process of taking what you're sending out, the HTML, into pixels on a screen. And these pixels usually are also somewhat interactive. You can scroll, you can click, you can do all sorts of things on a website that has been rendered. How does that affect us and our industry? Well, if you think about it, the server eventually starts responding with things, right? The browser assumes that you are opening a website, so it has a body. Eventually that body comes over from the server as well, and then in the body there might be some HTML elements. In this case, the browser basically starts creating a tree-like structure so that it has an interactive model of what exists on the page. As the HTML arrives, we have seen an H1. The H1 contains some text. The H1 might contain other HTML elements. These might contain attributes. These might contain other texts. You know, these resources can be more complicated than that, but fundamentally that's what happens. And as more HTML arrives, what happens in the browser is called parsing. So it basically goes and sees if it finds other completed elements. If it does, in this case, it finds a paragraph with some text, it adds that to this tree structure. Why are we dealing with that? Why do we do this? Why do we have to create like this weird mapping structure that maps the HTML? Why can't we just say we'll work with the HTML? The HTML itself is fundamentally just a bunch of text. You can't really do much with it. But if I have this structure, then I can say like, if I have this H1 and the user clicks on it, I want the website to do something. For instance, if I click on this, it needs to change the CSS on this, or if I click on this, I want this text to appear that hasn't been there beforehand. So this continuous process of adding things to this tree is a very nice process because it happens as the data arrives. So we don't have to wait for everything to arrive over the network until we can actually potentially see stuff. Using this wonderful tree structure, we can basically start to prepare displaying something. So rendering can happen while we are still downloading the HTML. This thing, by the way, is called the DOM tree. If you've not heard about that, there's a fantastic lightning talk about this, why the HTML that you're writing and that your server is sending is not necessarily the same as the DOM. The DOM is a in-progress kind of snapshot situation. So if I clicked on the H1 and that created an additional paragraph, then the DOM has changed. The initial HTML hasn't. However, this DOM might change at any point in time, and usually it is changed by using JavaScript. Aha! So JavaScript in this case fundamentally goes into this tree and says, in this tree find me the first H1 element, and then we go like, okay, so surprise, there's an H1 element right here. So this is now stored in the variable called headline. We can then change the text content here by saying headline's text content should just be high. So congratulations, your JavaScript has just mutated the DOM tree. The thing here is that not many people are aware of that this happens more or less on your website, and that per se is not a problem. If your website does this, fine, most likely. If you're changing 100% of the content, that's fine. Google doesn't care, because we are doing exactly this process. We're building this tree, we're executing the JavaScript, and eventually we take a DOM snapshot, and that snapshot is what we're using to index stuff, right? So as long as your JavaScript does it before we take the snapshot, and we're pretty good at figuring out when to take the snapshot, not always perfect, but pretty damn good, then you will be fine. The next thing that happens once you have created this DOM tree and potentially have changed it, or whenever you are changing it, so over the lifetime of a website, this DOM tree can continue to change, the browser has to figure out where things fit. If you saw Jamie's talk yesterday, you saw like the big purple parts. The purple parts in the graph is what's called layouting, and layouting basically goes like, so I have all this collection of things here. Let's start with this one. The H1 needs to go somewhere on the page. So far the page has been empty, so we'll put it here. And as it's a headline, it is very likely bold text, and it wants to take the entire width of that page. So we don't want stuff to show up here because this is a headline, right? You can use CSS to change that. You can in CSS say like, no, don't do that. Just put things on the back of that. That's perfectly fine. But in this case, we are assuming that there is no CSS. So the standard browser CSS goes, okay, we put that there, and then we have a paragraph and some text, so we're gonna fit that in here. And this is nice, this is useful, because beforehand we had a bunch of text, we had the HTML. You can't really do much with that, but here we know that this one spans an entire like vertical part of the page, and this one needs to put some text in here. If I resize the window, now, because we have these individual bits and pieces, I can say, okay, so maybe the window is now too small for this to fit here, so we can move it down here, and then it gets a little wider, and then this moves down a little bit, and that's exactly what layouting is. Layouting is fundamentally what you do after IKEA shopping. You're trying to fit your furniture into your apartment. And that's exactly what the browser does here. It received a bunch of furniture over here, and now it needs to fit it into the apartment that is the browser window. We do that, we keep doing that. And here it's interesting, here, assuming that we are still downloading the image, we're like, okay, so a paragraph also takes the entire width, and it takes just enough space for the text, and then there's an image there. Eventually that image is going to arrive from the network. Now when the image arrives from the network, we can go like, oh, okay, so now, okay, right, okay, this needs more space, and then the text probably disappears under the image, or in this case there is no text in the paragraph anymore, and then you actually put in where the image goes and how big the image is. So that's the layouting process. This layouting process is not a one-off, it can happen multiple times. For instance, if you're resizing your browser window, or if you're turning your phone from portrait into landscape and vice versa, what it has to do is the dimensions of the window change, so you actually have to re-layout things. Layouting is a relatively expensive process, so if you see a lot of purple in your performance graphs and DevTools, you don't want to see that. Here we have one of these pages. Here we see like this is actually downloading things, this is parsing some HTML, and this is interesting. So the little blue dots here, that's parsing HTML. And you see like it parses some HTML, there's some script attached to it, so that it runs some script. The yellow is running a script. And then here, you see this? There's like a bit of yellow happening, so JavaScript is running. And then there's a bit of blue. Why? Wait, where does that blue come from? This is HTML parsing. We've done this, right? Well, no. If JavaScript creates more HTML, then surprise, that has to be parsed, and that's exactly what's happening here. Then a lot more JavaScript magic is happening, and now it has done like all the work that it needs to do, and a lot of putting things into places are happening. This takes quite a long time, but that's not necessarily JavaScript's fault. It depends on how that's done. This can be a lot shorter, this can be a lot longer. This could also look exactly like this if there was no JavaScript, depending on how you build your HTML and your CSS. And then afterwards, there's some more downloads happening. And then here, the green peaks, that's when it actually paints stuff onto your screen. Not that we care too much, to be honest. The interesting thing about painting and the green thing is, why didn't I mention this before? Because we don't care. Google search does not need to put anything onto pixels. Why? What for? Everyone's like, oh, I need a bigger screenshot in Google Search Console. No, you don't. No, you don't. Why not? Because it doesn't matter what pixels are there. If you have some content that is hidden behind some carousel or something, it's still content. We still see that. We still consider that for indexing. The pixels don't matter. What matters is that it is in the DOM. Do you know where you find the DOM in Google Search Console? Show of hands. It's not enough hands. Rendered HTML in the URL inspection tool, yes. So you want to look at the rendered HTML in the URL inspection tool. That's where you find the rendered HTML. And that's the snapshot of the DOM that we took. So how does Google do it? The answer is a bunch of microservices, which is really helpful, isn't it? So I'll be the crawler. I just crawled a website, and now you are each of you is a microservice in rendering. So I'm just going to be like, here, I want this to bounce 3 times. 1, 2, 3, and can it come back to me, please? 4. Thank you. That was a microservice interaction. I passed it into a queue of microservices, and then these microservices made decisions. Let's call it decisions, okay, because that was not a good performance. Made decisions onto where to pass it on. And if I do that again, I'm passing it on again. 3 times. What the hell? At least 3. Okay, there you go. You see, I pretty much started off with the exact same interaction, but the thing that happened was very different. And this is why rendering is tricky, because this is exactly what happens when we are indexing a website. There's lots of different microservices that are talking to each other, and these can take different routes. I'll give you an example. So we crawl, we get back some HTML, we pass that over. And then a bunch of microservices run at the same time. I pass the ball over, there's deduplication, canonicalization. Canonicalization goes, I think this is not something that I have in the index already, so I'll pass this on to somewhere else. And then it passes it on to somewhere else, and that other thing might go, I'm very busy right now, I'm holding on to this ball for like another couple of minutes, and then it holds on, and then it holds on, and then it holds on, and then goes like, oh, actually this looks like an error page, so I don't think we need to process this further. At the same time, however, and that's where this metaphor fails a little bit, It's not a physical ball, so we can actually spread it out to multiple people. I can throw multiple balls for the same page into the microservice architecture. And basically, another service at the same time might have gone rendering. So, okay, so we run this in a Google browser and we download all the resources, and then we come back with an exam, like, here's our result. And then the indexing pipeline goes, yeah, but it already told us it's an error page. Bye. So that can happen. It is very complex to track these things, and the good thing is, you don't have to. Okay, that's our job. That's what we need to take care of, and there's like lots of them, and that's only very few. It's a small subset of what we have, but fundamentally the entire indexing pipeline is made out of these microservices. For instance, the robots parser that figures out if we can even crawl. The crawler actually needs to do stuff. The double elimination needs to do stuff. The links need to be parsed out. The content needs to be parsed out. We need to understand if this is a language version of the same content that we already have. Yada, 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 yada. And one of these many, many services is the web rendering service. The web rendering service is the magic that actually runs JavaScript. So very fundamentally, if you've ever used Puppeteer or Headless Chrome or Headless Chromium, that comes partially out of what we did for web rendering service as well. The rendering team has contributed large amounts of stuff for that. Fundamentally, what it does is it gets the HTML that was crawled beforehand from another microservice. It gets the resources from the crawler as well. Then it goes into this magic box, and out comes the DOM snapshot. This DOM snapshot on the very far right, that is what is being put into indexing. So no matter what you're trying to rank for, no matter what you're trying to get indexed, that's what it uses. Do you notice something? Do you see the word JavaScript here? If you do, drink less. The sun and drinking don't go well together. There's no JavaScript here because it doesn't matter if your website has JavaScript or not. It goes through the rendering process. It does create a DOM tree. That DOM tree is being used. That's why I'm very surprised that people are like, oh, if you are using JavaScript, it takes a lot longer to get indexed. I'm like, nope, it still goes through here. So no, it doesn't. And people are like, yeah, but the rendering queue was days. Was, but that's years ago, has changed since. We're pretty fast these days. So if you get something indexed fast, it's not because it doesn't or does have JavaScript, it's because of other things. And as you've seen this, there's a lot of other things that can happen. All right, so now what is this magic box? Because I've been cheating a little bit. I've been just being like, there's a magic box here. Let's open the magic box. Yeah, that's not helping, isn't it? So here we have indexing. That's the rest of the indexing pipeline, and this is where we cross into web rendering service. We have what's called a service wrapper. In the service wrapper, we have WRS, which is the web rendering service core, and the caching layer. The caching layer is quite important because we found out that actually what's really expensive and takes a lot of time is waiting for servers out there or the internet to work. Did you know, fun fact, did you know what's the biggest threat to worldwide internet traffic? No, sharks. Because sharks bite transoceanic cables. So undersea cables get bitten by sharks because sharks. So that's the thing. And cows, apparently. In rural America, cows are a problem. Because for some reason, someone thought like, oh yeah, overhead lines on poles that lead like fibers into data centers is a good idea. And then cows go, ooh, scratchy pole. That's nice. Anyway, so yeah. By the way, if you're using the URL inspection tools in Search Console, you are actually going through their backend for the testing tools, which directly talks to web rendering service. There's a very important thing here. If you're doing a live test, it talks directly to the web rendering service, does not use caching. Why would it use caching if it's a live test? That's the whole idea of a live test. The downside of that is that sometimes you get the other error. The other error is when something went wrong, duh, but the problem is it's not something that you can act upon. So if we don't have a cache and something in our infrastructure, because our infrastructure is built to crawl the entire freaking web, not in one specific website now, so it might be that it basically goes like, can you please crawl this for me? I have a user waiting. And then the crawling infrastructure goes like, I can do this in 5 hours, which for indexing is perfectly fine. For a user looking at a spinning loader is not great. You don't want to sit 5 hours in front of your computer waiting for a live test result. So in that case, we eventually have to be like, that took too long, sorry, we're trying again next time. and then we cut it off, and that's where these errors come from. Fundamentally, nonetheless, if things show up in the rendered HTML in the live test, that means that we can see them. More interesting is the view crawled page. The rendered HTML in view crawled page also shows you what we've seen when we last did this properly with the caching layer and everything. Inside this wonderful web rendering service core are instances of the renderer. The renderer has a bunch of orchestration, which basically means like let's run a bunch of different browsers on server infrastructure. It instruments them so that we can actually get data out of these little beasts, and then it collects a bunch of metrics. It has a pool manager that has a bunch of headless chromes, and if one of these dies, the pool manager goes like, oh, interesting, starts a new one, kills the old one, and basically fetches the job again, so we make sure that all the jobs are actually getting done. And these components play together to actually render stuff in Google search. The good thing is, again, none of this matters to you because we are taking care of that working. Just if someone thinks like, oh yeah, we should probably build our own web rendering service, good luck. It's hard. It's truly hard. The team is amazing. Zoe, Eric, all the others, they get far less love than they should get. Managing this is bananas. So, what do you need to know? What do you need to take away from this? All websites get rendered no matter if they contain JavaScript or not. What we see after the rendering, that's the DOM snapshot that will be taken into indexing. That's what you care for. Not the screenshot, not some weird cache on the search results. Don't use that. Don't use like view source. View source doesn't give you DOM information. Use the testing tools that we provide. They're actually giving you what came out of rendering. And median, a page is rendering queued for 5 seconds. So that means before one of these lovely ones picks them up, they're on median 5 seconds in there. 90th percentile is a few minutes. So we're talking minutes, not weeks or months. Rendering aggressively caches resources, so you don't need to worry too much about your crawl budget regarding rendering. It doesn't make that much of a difference. And if you want to test your stuff, do not do weird stuff. Just use Google Search Console's inspect URL. It shows you what happens in rendering. Okay? Don't be afraid of rendering or JavaScript. It's all in the tools. You can see it there. Which means I don't know how much time I have left, but if you have any questions, then I'm good. I have the I have the time. Yes. Oh, what's happening? Ah, microphones are happening. No, I get to do this.
So on Next.js, and I don't know if this is session, at every deployment of build, we build like new Next.js resources. So if you cache them, right, but they will be gone.
Yeah.
Next time you
Yeah.
deploy it.
So we're not caching the HTML, so the HTML is probably going to, you are probably talking about like fingerprinting, right? So you have like main.a059d76cd.js, yeah. So if the fingerprint changes, then the cache is invalidated. That is true, yeah. So that is...
Is that, I know this is like it depends kind of question, is that worse for performance then?
No.
Okay.
You're welcome. Good question. Question back there, far, far, far away.
Well, as you are talking about right now, you are telling that Google don't have any issue about rendering JavaScript, right?
Correct.
So, there is any problem about websites with client-side rendering. So, that would mean every rendering wouldn't make sense anymore?
So, if you are client-side rendering, there's many different ways of doing that. If you're doing it right, there's not a problem with client-side rendering, and there hasn't been a problem in the last years. However, because it offers a lot of creativity, let's put it that way, people driving cars are not a problem, right? Have you driven a car in Spain? I did from the airport. I beg to differ. So, and that's not just Spanish people, like Swiss people are bananas because Swiss people try to teach you something, you're just like 120 in the left lane and they're like, this is 100, I'm not going to show him. And you're like, but why? As your lunch is flying. Anyway, so fundamentally, if you're doing it right and you test it well, it doesn't cause a problem. However, you should know that SEO is not the only thing that you should care about. It does have potential performance pitfalls or potential performance problems that you do want to test very carefully, and server-side rendering can be a way to overcome these problems and generally offers a more robust solution, generally. Again, creative developers being creative can actually poop on your party like a seagull on your drinks. So definitely be careful with that, but it's not a fundamental problem to do client-side rendering in Google search.
So in conclusion, IB rendering wouldn't make sense anymore.
We are rendering, and it makes sense to do client-side rendering if it makes sense for your application.
Okay.
And every page gets rendered, so. Okay.
5, 4,
Oh, God.
4, 3, 2,